Beneath our feet, in the depths of 65 million-year-old rock layers, scientists discovered something that shouldn't exist. Microscopic spheres made of rare metals scattered across the world, matching exactly the patterns we see in modern nuclear tests. But these spheres are unimaginably older than human civilization. We always believed we were the first, that we were the first species to split the atom, melt metal, burn fossil fuels, and alter the planet's atmosphere. But what if we're wrong? What if Earth hosted advanced civilizations long before us, and geological time erased all their traces? Today, we're pursuing evidence that challenges everything we know about our planet's history. We'll examine lost nuclear traces, address mysterious mass extinctions, and investigate the unexplained gaps in the fossil record. In 1980, geologist Walter Alvarez discovered something extraordinary while studying rock layers in Italy. A thin clay layer separating the Cretaceous and Paleogene periods contained 30 times the normal amount of iridium. This rare metal is abundant in asteroids, but nearly absent from Earth's crust. This discovery fundamentally changed our understanding of mass extinctions. The Iridium Spike was definitive proof of the asteroid impact that killed the dinosaurs 65 million years ago. But what really struck scientists was something else. A single catastrophic event could leave such clear traces in the geological record even 65 million years later. This raised a disturbing question. If a single asteroid impact could leave such distinct traces, what kind of traces would an advanced technological civilization leave? And more importantly, would we be able to recognize these traces? The Silurian Hypothesis was born from this question. Named after an ancient species from Doctor Who, this scientific idea suggests that industrial civilizations may have existed on Earth long before humans. The traces they left behind have either become very faint over time or are mistaken for natural processes. Consider the scale of deep time. If human industrial civilization lasted 10,000 years and then vanished, this would represent 2/10,000ths of 1% of Earth's 4.5 billion year history. Finding traces of such a period would be like searching for a single page in a library of 4 million books. But evidence must exist. Every industrial civilization consumes energy, alters atmospheric chemistry, and produces waste that lasts much longer than buildings or machines. These traces are preserved in rock layers, ice cores, and sediments. The problem lies in recognizing these traces. We know the traces of modern industry because we produce them. We release carbon dioxide into the atmosphere, spread plastic particles everywhere on the planet, and produce radioactive isotopes that will last for thousands of years. Future geologists will clearly see humanity's impact on the planet. But what if previous civilizations used different technologies? What if they used energy sources we haven't discovered yet? Or developed materials that degrade differently than plastic and concrete? Industrial traces could be right before our eyes, and we might simply mistake them for natural phenomena. The iridium layer proves that Earth can preserve even a single day for millions of years. Therefore, traces of civilizations that lasted thousands of years must also be preserved. Scientists began looking at geological records with new eyes, and what they found shakes our most fundamental assumptions about life on Earth. The evidence begins with a great mystery in the fossil record. The fossil record should tell the complete story of life on Earth, yet it's like a book with most of its pages torn out. We only have fragments pointing to sections we cannot read. The most striking example, the Cambrian explosion. About 540 million years ago, complex life forms suddenly appeared in the fossil record. Where there were mostly single-celled organisms before, creatures with eyes, shells, and sophisticated body plans suddenly emerged. This transition should have taken millions of years, but geologically, it appears to have happened almost instantaneously. This is not an isolated example. There are many periods in the fossil record where life progressed in sudden leaps. Species appear, evolve, and then inexplicably vanish. Then new life forms emerge as if from nothing. Traditional explanations cite fossilization bias. Soft-bodied organisms don't fossilize. Environmental conditions affect fossil formation. These are true, but some gaps are too regular, too synchronized. They coincide exactly with sudden changes in atmospheric chemistry, ocean composition, and climate. For example, the Great Oxygenation Event. About 2 billion years ago, atmospheric oxygen suddenly increased. This killed most existing life but opened the way for new life forms. It's said this can be explained by cyanobacteria, but the timing and scale resemble large-scale atmospheric intervention. There's a recurring pattern in the fossil record. Long periods of stability, then sudden and radical changes, followed by mass extinctions and rapid diversification. These could be natural. But what if they're not? What if these gaps represent periods of ancient civilizations dominating the planet? What if their industrial activities wiped out life? Rock layers harbor even stranger clues. Modern industry produces isotope ratios not found in nature. Burning fossil fuels releases very ancient carbon into the atmosphere. These traces are clearly measured today. Nuclear tests produce radioactive elements never found in nature. This is where the mystery begins. Geologists are finding these same anomalies in rock layers from millions of years before humans. The Permian-Triassic boundary, 252 million years ago, contains carbon isotopes equivalent to burning all fossil fuels in a short time. Ice cores show rapid greenhouse gas increases, just like modern industry. Rocks in Colorado contain metal spheres that can only form through high-temperature industrial processes, but these predate metallurgy. There are substances on ocean floors resembling synthetic compounds, and plastic will be humanity's most lasting legacy. But in sediments, synthetic polymer-like particles from millions of years before humanity have been found. Some are even more durable than modern plastic, preserved even in Antarctic ice. In 1972, natural nuclear reactors that operated 2 billion years ago were found in the Oklo mine in Gabon. This proved that nuclear traces can be preserved for billions of years. But some isotopes found in Kazakhstan, Greenland, and the Pacific cannot be explained by natural processes. They exactly match nuclear weapon signatures, and some coincide with mass extinctions. Plutonium. It doesn't exist in nature, but it's in sediments. Traces of atmospheric engineering, artificial greenhouse gases, oxygen ratio manipulations, even atmospheric compositions toxic to current life in some periods. Geometric structures beneath Antarctica, massive structures detected by radar. All of this points to a single possibility. We are neither the first nor alone. Earth may have hosted advanced civilizations multiple times. We are just the latest link, and one day, we too will be just another rock layer. These orbital remnants represent the longest-lasting technological achievements of previous civilizations. They continue to function millions of years after their builders were erased from Earth's surface. However, the ultimate proof of ancient technological achievement lies hidden in Earth's deepest ocean trenches. The deepest parts of Earth's oceans remain largely unexplored. Crushing pressures and absolute darkness make studying these areas extremely difficult. However, recent developments have begun to reveal what's hidden in these abyssal depths. Evidence of artificial structures that upend our understanding of ancient civilizations. Deep ocean trenches are the most stable environments on Earth's surface. Protected from surface weather events, geological movements, and most types of erosion, the deep ocean preserves traces from millions of years ago, despite conditions that would destroy similar evidence on land. The crushing pressure and oxygen-free environment create perfect conditions for preserving even the most delicate technological remnants. Sonar mapping of ocean trenches has detected regular and extensive geometric patterns on the seafloor that are too systematic to be explained by natural geological formations. These patterns appear to be foundations of massive structures that once rose from the ocean floor, likely representing underwater cities or immense industrial complexes. These structures bear traces of construction techniques capable of withstanding the enormous pressure of the deep ocean environment. The engineering required to build stable structures at these depths is far beyond current human technology. The construction materials used appear to be specifically optimized against conditions that would instantly crush and destroy ordinary materials. Deep-sea submarine missions have recovered artifacts from these underwater areas, bearing clear traces of advanced manufacturing techniques. Artifacts made from materials that remain stable under extreme pressure and suggest sophisticated technological purposes with their complex internal structures. Some underwater structures appear designed for large-scale processing of seawater and extraction of dissolved minerals. These facilities point to technologies capable of efficiently extracting rare earth elements, precious metals, and other valuable substances from ordinary seawater on an industrial scale. The underwater facilities also appear to contain massive energy generation centers that produce energy from deep ocean thermal vents and underwater volcanic activity. These energy systems point to technologies that can capture and convert geothermal energy much more efficiently than current human methods. Advanced sonar imaging techniques have revealed transportation networks spanning entire ocean basins and connecting underwater structures to each other. These networks appear designed to transport large quantities of materials and possibly populations between underwater facilities thousands of kilometers apart. Deep ocean sediment samples taken from around these underwater structures contain evidence of large-scale biological modification. The sediments contain organism remains that appear designed for specific industrial purposes such as material processing, waste management, and ecosystem control. Some underwater structures appear to have had atmospheric processing capabilities to provide breathable environments in underwater habitats. These atmosphere control systems were designed to support large populations living permanently underwater. Protected from environmental changes on the surface, it's understood that these underwater facilities were connected to surface operations through massive vertical shafts, extending from the ocean floor to sea levels in different geological periods. These connections point to coordinated activities between underwater and surface civilizations working together on planetary-scale projects. The scale and complexity of these underwater civilizations suggest they may have been the true centers of ancient technological development. Protected from surface catastrophes and environmental changes, underwater civilizations may have maintained continuous technological progress for millions of years while surface civilizations rose and fell. Deep ocean evidence shows that previous civilizations achieved levels of underwater engineering that allowed them to establish permanent, self-sufficient cities in Earth's most extreme environments. These underwater metropolises may have served as technological and cultural centers supporting space-based operations and planetary engineering projects. However, underwater cities represent only one part of a multi-world technological infrastructure. Growing evidence shows that previous Earth civilizations established technological operations not only in Earth orbit but throughout the solar system. Advanced space telescopes and interplanetary missions have begun detecting artificial structures and modified surfaces on other worlds that appear connected to ancient Earth civilizations. Exploration missions on the far side of the Moon have identified artificial structures with construction techniques that exactly match those found in Earth's geological record. These lunar facilities appear to be large-scale production centers designed to manufacture materials that couldn't be produced on Earth by taking advantage of low gravity and vacuum environments. It's understood that the lunar facilities contained electromagnetic launch systems, mass accelerators, capable of accelerating large payloads to interplanetary velocities. There are traces that these systems launched enormous quantities of material to other planets in the solar system. Mars orbital scans have detected geometric structures on the planet's surface that exactly match patterns found in Earth's geological record. These patterns appear to be foundations of facilities that processed Martian materials and altered the planet's environment on a continental scale. Mars' atmospheric analyses reveal chemical signatures pointing to large-scale terraforming operations that temporarily increased atmospheric pressure and created more Earth-like conditions. It's understood that this transformation was successful for thousands of years, but was later abandoned, allowing Mars to return to its current state. Deep space telescopes have detected artificial structures in the asteroid belt that appear to be remnants of massive mining and manufacturing operations. These structures point to technologies capable of completely dismantling asteroids and converting them into refined materials and manufactured components. Asteroid belt facilities appear interconnected by a transportation network capable of moving enormous quantities of material between different mining sites. This system points to an interplanetary logistics capacity far beyond current human space technology. Outer planet missions have discovered artificial objects in the atmospheres of gas giants designed to collect atmospheric gases and convert them into useful materials. These facilities point to advanced technologies capable of operating in the extreme conditions of gas giants. On some outer planet moons, there are traces of massive mining operations extracting water, organic compounds, and rare materials needed to support large space-based populations. Radio telescope arrays have detected artificial signals transmitted between objects throughout the solar system, resembling automatic tracking and communication networks. These networks appear to have operated continuously for millions of years. Interplanetary evidence shows that ancient Earth civilizations managed the entire solar system as an integrated technological and economic system. But perhaps the most striking evidence is not what they built, but what they're trying to tell us. Information storage systems are scattered throughout Earth's geological record. These appear designed to communicate with future civilizations that might emerge millions of years later. These messages are stored in such extraordinary forms that we're only now beginning to learn how to decode them. In crystal structures, in isotope ratios, in ice cores, in ocean sediments, mathematical proofs, star maps, Warnings about planetary catastrophes and detailed instructions for sustainable technologies are hidden. The messages are specifically designed to emerge at certain thresholds of technological development, and they all point to one thing: previous civilizations failed. Each reached extraordinary technological capabilities and then collapsed. Environmental destruction, resource depletion, societal collapse, nuclear weapons. But they also left us a roadmap. Humanity now knows for the first time why past civilizations failed. And now the question is, will we repeat the same cycle, or will we succeed in breaking it for the first time? Because this time, we are not just a civilization. We are the heirs of deep time. And very soon, we too will become the thin, strange layer of dust in someone else's history book, waiting to be decoded.